What is poppin' dogs? Mr. Allen here getting tricky with it in this video, and I've got three different examples for you. One where we got to solve for an angle, one where we're solving for a side, and a scary application problem involving the one and only Snoop D-O-double-G. All right, since we are getting tricky with it, you're going to need a calculator. I'm going to show you guys how to use that thing right now. First one, solving for an angle. Whenever I'm solving for an angle, I'm going to use inverse trig. There's a way to algebraically show it. I'm going to link a video on how I did that, but I like to go shortcut way. Inverse trig for solving for an angle, regular trig when I'm solving for a side. But I still got to label my triangle. So with respect to this angle right here, x, that I'm solving for, the opposite side, OPP, is right over here, and my adjacent side is right here, okay? My hypotenuse, I'm not asked for it, I don't need it, so I'm really only working with those two. So which trig function am I going to use? Might be helpful to jot down a little SOHCAHTOA action real quick. We have SOH, that's sine is opposite over hypotenuse. Cosine is CAH. And then we have tangent opposite over adjacent. All right, so commit that to memory. It's an acronym that helps us remember what it is. Those are my ratios. This means that tangent is the opposite over the adjacent. And since I'm solving for an angle, I'm going to use inverse. We're going to do tangent inverse of my opposite side, which is 14, over my adjacent side, which is 19. Now, do you think this angle is going to be larger than or smaller than 45 degrees? And why did I pick 45 degrees? Well, this is 90 degrees right here, which means there's 90 left over for the other two angles. If they were equal, they'd be 45 and 45. So you're either going to be more or less than that. It's kind of like the halfway cutoff. Since this side is smaller than this one, the one that's across from the angle is smaller, I should get something that is smaller than 45. Now, it's not terribly important right now, but when you get into later trig and whatnot, you do want to pay attention to smaller side has the smaller angle across from it, and the larger side is going to have the larger angle across from it, okay? So let's type this thing in here, and hopefully you guys get the same answer. If not, we're going to go through it, okay? Second tangent, and then I have my 14 divided by my 19. Hit enter, and I get 36.38 degrees. Now, if you didn't get that, it's likely because you are in radian mode. I hit the mode button right next to the second button, and right down here you see radian. Did you get this answer? If I hit enter, 0.635. Yeah. It's not what we want. Those are radians, which are useful in math, just not in right triangle, trigonometry, in geometry class, or even usually pre-calc class. We're working with degrees. Either we're given degrees or we're asking for an angle to be in degrees. So I'm going to hit mode. Once again, get that back into degree mode. If you don't have that, go hit mode, choose degree, hit second, quit, and we'll type it in again. If I hit second tangent, all right, break that down. The second is that blue button up there. I'm going to type the 14 over the 19 and 36.38 degrees. So let's jot that down. 36, x equals 36.38 degrees. Usually I do 2 decimal places, so that's what I'm going to do here. But there we go. Cool. Awesome. You can actually do this stuff also, by the way, out in the wild, if you will, and like go to like a railing of a staircase and measure your rise and your run. Do tangent inverse of it. It'll give you the angle. You can check it with like your phone has like a level app where it'll tell you the degrees. Kind of cool to see actually in action. All right, next one here. I'm solving for a side, which means I'm going to use regular trig. So first things first, though, I'm going to label my triangle with respect to the angle that is given or the angle that we were looking for. The 18 right here is next to it. It's the adjacent. And then across from my right angle is always my hypotenuse, HYP. I'm hyped on that. All right. So what trig function am I going to use? SOHCAHTOA, adjacent over hypotenuse. What I have and what I want, cosine's the move. All right, so I'm going to do cosine of that 27 equals my adjacent, which is 18, over my hypotenuse, which is x. And now I need to solve this equation. And you're going to notice a similar pattern each time. You might try to take a shortcut. Be careful. Make sure you still know how to do algebra, even though you're going to try those shortcuts. But I'll explain both right now for you. So first off, I can't just like divide by 18 and get x by itself because x is in the denominator, right? So I got to get the x out of the denominator first. And I'm going to do so by multiplying by x on both sides. So that's going to cancel that x right there, leaving me with x times the cosine of 27 degrees equals 18. Now, it might seem weird, but cosine of 27 cosine of 27 is just a number. So I have x times a number. How do I get that x by itself? Divide by that number. Now, I'm going to type this all in at the calculator at once, right? YOLO, you only round once. I don't want to round that to 0.89 and then calculate with that. The answer is going to possibly be a little bit off. Sometimes worse than others, but I like to be as accurate as possible, right? You know, divide by cosine of 27 on both sides. Those are gone. And now I'm left with x on the left-hand side here equals 18 over the cosine of 27. So let's get what x equals right now and be on our merry way to the application problem. So 18 divided by cosine of 27 degrees. Hit enter, 20.20. All right, so 20.20 inches. And you could put just 20.2, that's totally fine. I was doing 2 decimal places, so that's what I did. In certain ones, like a math team competition, if they say 2 decimal places, you actually have to put the 0, or they will mark it wrong. They're sticklers. But we're not a math team right now, right? We're just mathing right here. So, anywho, cool, awesome. And I did say that sometimes, like, if you were to round that 0.89, if I did 18 divided by 0.89, instead of just the cosine of 27, I get 20.22. So 200ths difference, not a huge deal like if you were actually applying this, but it is still slightly different. And if I'm grading it and I'm going by the law of YOLO, you only round once, I would mark it wrong, okay? And that might seem mean, but we're just using the values in our calculator. Imagine if I did this, 18 divided by 0.9. What if I rounded the nearest tenth? Oh my goodness. Now I get 20 on the nose. That seems like it's exact, and it's not, okay? So use the calculator, right? It's helpful. I can type it in exactly like that. 18 divided by cosine of 27. Easy peasy. All right, last one here. We got Snoop, D-O-double-G. Stands 48 feet from a building and observes, should be plural, and observes an angle of elevation of 52 degrees. Okay, so he's standing there, and he's looking up at the top of the building, 52 degrees up. And that's from eye level, right? I don't know actually how tall Snoop is. 5'9", that sounds about right for eye level. And he's got a little more forehead. He's probably 6 something, right? I should have looked this up. Anywho, how tall is the building? Interesting. I can figure it out all from that. Yes, you can. We've done it. Okay, we've mathed in the wild on something like this, and it is pretty darn cool. So let's draw a picture up, shall we? So I'm going to draw a little building here. I will do it in orange. I'll just do it off to the side here, and then we'll math right here. So we've got some building that we're trying to find the height of. Right? And then we'll get some ground here. We'll do the grass right here. Whee! Okay. And then maybe like Dr. Dre's chilling up here, right? He's like, what up, Snoop? Come to the studio. We're going to drop that new album. Maybe, right? And there's, of course, a railing there for safety purposes. Okay. All right. And then Snoop's somewhere over here. Forgot about Snoop for a sec. He's chilling. And he observes this angle. Ooh. Let's bring out the straight edge, man. Let's bring out the straight edge. He observes an angle to the top of the building from that eye level, and his angle of elevation is 52 degrees. Now, that's off of horizontal. So from here, then looking up, okay? Horizontal. So I am going to draw a horizontal line. Hopefully it's pretty darn horizontal. And this is a 52-degree angle of elevation. And he's standing how far? 48 feet. So 48 feet, whether that be from like here to the building or from here to here, right? It's all the same. Whether you're talking about on the ground or up here, they're parallel. These lengths will be the same. And I want to figure out how tall that building is. Well, the way I have it set up currently, I can solve for this length, but that wouldn't be the whole thing. So what do I need to do? Well, we said Snoop is 5'9", right? 5'9". I could just add that to it, right? Okay, but let's see here. I got a lot of units going on, right? I got a lot of units. I got 48 feet. I got 5'9". Perhaps I can convert this guy into just feet, into a decimal, and it'll be a little easier to math with, okay? So 5'9", how do I convert that? Well, 9 inches, there's 12 inches in a foot. So if I took 9 and divided by 12, and you might be like, hey, that's 0.75. You are correct. So that would be 5.75 feet. So I'm going to write that down. 5.75. right, so now I got everything in feet, 5.75 feet. We got a distance of 48 feet. I can math with that. If I'm in different units, cannot math yet, all right? Now, not every teacher is going to give you a situation where you have to convert inches and feet. I do that a lot in my geocon class because it's very applicable when we're out in the field. Just make sure you're reading the prompt and taking everything into account. All right, so I think it's time to set up a little trig function. But which one do I want to use? Not want to use. Which one do I have to use? I don't really have a choice. Well, with respect to my 52-degree angle here, the 48 is my adjacent side, whereas the x is my opposite side. So, toa, tangent is the move. It's the opposite over the adjacent. Let's set that thing up. I'm going to have tangent of 52 degrees equals my opposite x over my adjacent 48. Beautiful. This is the easy algebra, right? Only one thing to do. Multiply by 48 on both sides. Those are gone, and I'm left with just x by itself. I'm going to rearrange things here. We got x equals 48 times the tangent of 52, and I can plug that into my calculator. So let's do it. 48 times tangent 52. Boom, 61.437. Is that my final answer, by the way? I'm going to write it down. I'm going to write it down real quick. X equals 61.437 and change. I always put a little dot, dot, dot with 3 decimals when I'm not done mathing yet, and we are not done mathing yet. What do we have to take into account? The eye level, Snoop's eye level of 5'9" or 5.75 feet. I got to add that to it, and then we get the total building height. So let's do that. I will put this in blue because that's in blue, plus 5.75. What's that answer going to be? Let's see here. Plus 5.75. 67.187. I did not plan that, and that is definitely a bar from Snoop. 187. Okay, 67.19. I don't remember what it's probably inappropriate, but it's exciting that it worked out that way. There we go. Building height, 67.19 feet. When I round it, that is the last time I'm going to do any kind of rounding, or the only time I'm going to do rounding is at the very end, right? Everything else stayed in the calculator. One time. Round one time. Yo, bro, you only round once. All right, guys. Thanks for mathing with me. I know it's a long video, but 3 different scenarios. If you can handle these 3, you're pretty much set for your trig unit, honestly. There are different scenarios of solving for sides. We actually covered both here where the missing variable is in the denominator, here where it's in the numerator. Those are your 2 scenarios. And when we're solving for an angle, what do we use? Inverse trig. All right, thanks for watching, guys. Have a wonderful, fantastic day. And if you have any questions, pop them in the comments. See you later.